Once again, let's start it. In this diagram you can see that we are having one enterprise network for Network Bulls Technologies Private Limited, which is running AS65500, right? And it is a customer which have taken multiple internet connections, like from Sprint US. This is one of the service provider, right? And then they are also having two different internet connections from BT, from same service provider, right? So totally they are having three links: link 1, link 2, link 3. I mean, this customer Network Bulls. Fine. Then ISPs like Sprint and BT, they are interconnected with each other, right? Sprint is using AS21505, whereas this BT is using AS35500. Then this New York router is also there, that is placed in New York itself, and which is connected with BT, British Telecom. I mean, they have got connection from BT, and New York router is running AS8127. So this is the diagram actually, and with using this diagram I'll be performing all the required practicals in BGP. Fine. And one more thing I would like to tell you, that here internally in this enterprise network, like I'm talking in perspective of Network Bulls Technologies, internally we have configured OSPF area 0, right? So if R1 wants to reach R6, then of course it can reach it with the help of OSPF. So OSPF is running internally, and BGP will be running on the top of the OSPF over here, right? Like if we want to configure BGP peering in between R1, R5 and R1, R6, so we can form neighborship between them with using their loopback interfaces, because we have already configured OSPF between them. So now their loopbacks are, their loopback interfaces are reachable to each other with the help of OSPF. So it is possible to configure indirect neighborship in between R1, R5 and R1, R6 with using, with the help of their loopback addresses, because loopback addresses are already advertised in OSPF. Fine. So hopefully you have understood now this diagram, right? And now after it, let's have the console of R1. I'll be taking console of all devices, not all devices actually. First of all, I just need to have console of R1, R5, R6, and Sprint, BT, and finally New York router. So I'll be taking console of R1. So this is the console of router 1, right? And then I'll be taking console of R2. It's not required actually. I don't think so that it will be required anymore to have console of R2. Actually on R2 I already configured BGP, so let me remove that. No router BGP 65500. Fine. Then I'll be taking console of R5. Then I'll be taking console of R6. And then I'll be taking console of Sprint US. And then of course I'll move on BT, and then finally I'll be taking console of New York router. Fine. Fine. Now we can look at R1. First of all, I have to configure R1 so that R1 will form neighborship in with R5 and R6. I'll be configuring indirect neighborship between them. So let me do that. So I'll be saying router BGP. I think I have already discussed about default address family and all, like how to activate neighbors in BGP, is not it? I already discussed all those things, right? Like in BGP by default we are having address family for IPv4. That is why neighborship comes up automatically, right? If you disable that default address family, then you have to activate. You will require to create address family manually, and then you have to activate your neighbors, right? So we are already done with all those concepts, right? So now I'm simply saying router BGP 65500, and neighbor is going to be 150.1.5.1. This is the loopback address of R5, right? And then I'll be saying that remote AS is going to be 65500, right? And then along with that I'll be saying update source is loopback 0, right? Then after I'll be saying neighbor 150.1.6.1 remote AS, that is the address of this address belongs to R6 actually. So on R1 I'll be saying remote AS is 65500 now, and then neighbor 150.1.6.1 update source is loopback. I'll be saying 0, right? And then finally do show run pipe section router BGP. Let me show you that this is the configuration which we configured on R1 router 1, right? And then after you see show IP BGP summary, and you can look at here that you see it's not 8. So this time it is having neighborship with 5 as well as with 6. Similarly I'll move on R5 and I'll do configuration related to BGP on R5 as well. No CDP run, do show run pipe section router BGP. Check it out, BGP is pre-configured here. As you can see that for neighbor 150.1.1 it is already configured. Next hop self is also configured because it will be receiving prefixes from its eBGP neighbor and will be forwarding them to iBGP neighbor. That is why I have configured next hop self command over here. Then you can also look at this configuration like it is also having neighborship with 2. However, I don't need to form neighborship with 2. So what will I do now? Router, I will remove this command from here, router BGP 65500. I'll be saying neighbor 150.1.2.1. I'll remove this neighbor because I don't need this neighbor at all. I mean for now. Then although I'm not required to configure neighborship in between R5 and R6 as well, so because here it is already configured, so I'm going to remove it as well. 150 that is 56.6, right? So I'll be saying no neighbor 56.6. so I have removed it now, and now you can see show IP BGP summary. It will be having neighborship with 1 and of course with like Sprint US, and the IP address of Sprint US is what? 205.100.100.10. that is this one, right? And then after you can see that 200.105.100.1 is configured at the end of British Telecom. So right now this R5 is having neighborship with BT as well as with Sprint US. If we talk about the BGP peering, right? So it is having 2 BGP peers. One is Sprint US, another one is British Telecom. Then R5 is further having BGP peering, iBGP peering with R1. Fine. So it will be receiving all external prefixes coming from BT as well as from Sprint US, right? And you know very well that by default BGP behaves like distance vector routing protocol. Like in distance vector routing protocol, what happens that it will advertise only and only best path information towards its neighbors. Similarly in BGP, like if any BGP router receives any some of the prefixes from multiple neighbors from multiple devices, then it will define any one of them as best path, and then it will advertise only best path information towards other peers, other neighbors, right? Fine, that's true. So finally let's move on R6, and on I will modify some configuration of R6 as well, because BGP is already configured over here. Router BGP, that is 65500, and then I'll remove 2 first from here because I'm not having neighborship with that, and then of course 56.5 as well, right? And then further you will see that now it will be having neighborship with 1 and of course with BT, and British Telecom is having an IP address 201.100.100.1. You can look at diagram as well, right? So this time this BT is having this IP address, right? Is it visible or so any problem till now? Sure? Fine. Now finally I will move on New York router, and on New York router I'm having IP addresses like 191.60.100.100 and all these things, right? So let me configure them. 168.100.1 loopback 2, it will be having 101. Loopback 3, it will be having 102. Loopback 4, and it will be having 103. That's fine. So I'm having all these 4 prefixes over here, right, on Neo router. So IP interface brief, you can look at here, and you will find all these 4 loopbacks are available on this Neo router. Fine. Then after, you can look at show run pipe section router BGP. I mean, you can look at the configuration of BGP. In BGP, we advertise like 111 and 112. So I have to remove all those commands, and then it is running 8127, right? So I have to remove all these commands from here because these prefixes are not longer available in its local routing table, right? So I will be saying network 192.168.100.0 because it is a classful network, so I don't require to specify mask value, right? So 103. So this time you can look at here, so IP BGP. So you have advertised all these 4 prefixes, and you must remember that if next hop is 0000, which specifies that it is self-advertised, right? So in case if in BGP, if you are having a prefix available in your BGP table with the next hop 0000, which means that it is self-advertised, right? Then after, we can move on R1, and on R1 I can do one more thing, like show IP BGP. I must receive all those prefixes. See, this time R1 is receiving all these prefixes coming from R5 as well as from R6, and next hop is was automatically modified by R5 and R6 both. You know why? Because I configured next hop self command on R5 and R6 both routers, right? So that is why here all these prefixes are coming on R1, and you know, they are best actually, but best is via R5. You can look at here that best path is via R5. Any problem? So for all prefixes, as you can look at here, so IP route BGP, if you look at the BGP table, then you can see that in routing table it has installed all these prefixes via R5 only, via R5, and AD value is what? 200, because for R1, R5 and R6 both of them are working as an IBGP. I mean, both of them are IBGP neighbor. So if you receive any prefix from your IBGP neighbor, then by default its AD value will be 200. That is why it is showing you its AD value as 200 in its routing table, right? So in this way, now all these prefixes which are located on New York router, right, are present in the BGP table of R1. R1 is receiving them from R5 and R6. Now I'm gonna to teach you BGP path attributes. Today we will start from BGP path attributes. So let's start it now. So you can look at here on R1. R1 is receiving these prefixes, all prefixes coming from both neighbors, from R5 as well as from R6. Now if you look at that sequence in which I told you BGP path attributes, this is the way, or this is the sequence in which BGP will be comparing BGP path attributes for its best path selection, right? So I have already told you all those things. So first of all, it checks what? Next hop reachability. If next hop address is not reachable, then you know very well that BGP will never define that path as a best path, right? So first of all, it checks its next hop reachability. So this time its next hop, whether it is the loopback of R5 or loopback of R6, both of them are reachable. Even you can try that, ping 150.1.5.1, yes, and ping 150.1.6.1. so next hop is reachable via both. Now what can I do? I can do something so that, you know, like on R5 I will remove this command, next hop self command. I can remove that command, right? You see, do show run pipe section router BGP. Let me show you router BGP 65500, and then if you remove this next hop self command from here, you will see that now R1 will start receiving all these prefixes coming from R5 without changing next hop address, and at that moment you will see that its next hop address will not be reachable anymore. And if its next hop address is not reachable, then you can look at here, then it will never become now best, and you can see now its best path has become via R6, because via R5 its next hop address is not reachable. Any problem? IP route BGP, check it out. So next hop must be reachable, right? Fine, let's move back again on R5, and once again I'll be saying that next hop self. Once I'll configure this command, now R5 will start advertising all the prefixes in the direction of R1 after changing their next hop. And now you can look at its BGP table. Once again, its best path is become via R5. Why? So first of all, it compared its next hop. If next hop is reachable via both neighbors, then it will be looking at weight value. You can look at this. Weight is by default via both neighbors is 0. Then it will be looking at local preference. Local preference is also 100. Then it will be looking at self-originated, but this time this prefix is not self-advertised, right, by router 1. This time it is receiving it from its neighbors only, right? So it is not self-advertised, so that attribute will not take place. The next is going to be AS path attribute. So if it is going via R5, then it has to across 35500, sorry, via R6, 35500 8127. If it is going via R5, then also it has to across 35500 8127, which means that via both neighbors it has to across 2 ASs, which is again same. So AS path attribute is also same. The next is going to be origin code. You can look at this. This is origin code. Remember that if I is mentioned in the end of the line, which means this is your origin code. But if it is mentioned in the beginning of the line after star and this, you understand, greater than symbol, which means that it is an internal prefix, which means that it is received from an IBGP neighbor, right? So if I is specified in the beginning of the prefix, which means that it is an internal prefix or it is received from an IBGP neighbor, right? And if I is mentioned in the end of the line, which means that it is an origin code, right? So this I is specifying here origin code, and this I is specifying that it is an internal prefix, which means that it is received from an IBGP neighbor, right? So I hope that you have understood it now, right? So this time you can see via both neighbors, via R5 as well as via R6, its origin code is what? I. हाँ मुझे पता है, हाँ तो उसके लिए कुछ नहीं हो सकता बॉस, हाँ तो अब कंफ्यूजन को कंफ्यूजन ही रहने दो, मैं करा चुका हूँ सर, मुझे पता है बट थोड़ा कंफ्यूजन उसको आईडी होता है वो आए नहीं थे आप, हाँ तभी तो कह रहा हूँ, हाँ क्लास से पहले या बाद में ऐसी चीज़ें जो चीज़ें कवर हो चुकी हों. So this time origin code is I, right? So which means that it was advertised with the help of network command in BGP, right? So you must remember that origin code I would be attached to all those prefixes which are advertised into BGP with the help of network command, right? So this time origin code is I, and here you can see that via both neighbors its origin code is same. So which means that path selection was not performed based on origin code as well, right? So fine, origin code is also common. Now they will be comparing their metric, which means MED, multi-exit discriminator, right? So you can look at here this metric is also common this time via both neighbors, so it is not going to select its best path based on MED as well. So next attribute was external was preferred over internal. External, I mean EBGP was always preferred over IBGP, but this time you can look at here that via both neighbors this prefix is coming as internal prefix because both neighbors are IBGP neighbors. If one was EBGP neighbor, then of course it should have preferred that EBGP prefix, right? But this time because both neighbors are IBGP neighbors, so from both neighbors it is receiving this internal prefix. Fine. So it is not gonna to select its best path based on external and internal. The next is going to be IGP course to reach next hop. So right now you know very well over here that we are running OSPF in the background of the BGP, right? And of course to reach the loopback of R5 and R6 we are running here OSPF, and OSPF must be having some metric to reach them, right? So and it will be cost. So now BGP will be comparing IGP cost to reach next hop addresses, right? So what can we do now to compare that? Actually we'll say that show IP route 150.1.5.1. So what is the cost to reach it? It's 12, right? And if you look at SWIP route 150.1.6.1, what is that? 75. So of course, via R5, it is having lower ICP cost to reach next hop, right? So which means its best path will become via R5. Even you can look at here SWIP BGP 192.168.100.0. Check it out. This is the way to check your BGP table in more details, right? If you simply say SWIP BGP, then it will show you only and only, it will display only BGP table, right, with brief information. But if you wanna see each prefix with more details, then you can run this command SWIP BGP and your prefix, right, prefix value. So now you can see that it is received from R6 as well as from this one, right? One more thing I would like to show you here. This is next hop address. This is the next hop address, and the total metric to reach this next hop address is 75. Fine. This is your neighbor's IP address. From will specify your neighbor's address, and in this bracket this value will specify neighbor's router ID. In brackets it will specify neighbor's router ID. So right now, because we configured IBGP peering with using their loopback addresses, and BGP was using this loopback address as router ID as well. That is why both values are same, neighbor's address as well as neighbor's router ID. Similarly here, this is the next hop address, and this is the metric to reach this next hop address, and this is neighbor's IP address, and this is neighbor's router ID. Any problem? So that is why for all prefixes, its best path is via R5. But in case if ICP cost to reach next hop is also same, then what will happen? Let's check it out now. So we have to define its ICP cost to reach next hop as same via both neighbors. We can achieve it. You see here we are having 100 Mbps link. Here this is 10 Mbps link. On loopback interfaces by default their cost is what? 1. So 1 plus 100 MB, for 100 Mbps its cost will be 1. 2 plus 10 Mbps it will be 10. So that means that from R1 the total cost to reach the loopback of R5 will be 12, and this is the best path, right? Because it can also reach this loopback of R5 via R3, that is having serial link, and as well as this R1 can reach the loopback of R5 via R2 as well, but via R2 and via R3 its cost will be higher than via R4. So via R4 the total cost to reach loopback of R5 is 12, whereas to reach the loopback of R6 it will be like 10 plus 64, 74 plus 175, because on loopback interfaces by default their cost is what? 1. So this time its cost is 1 on R6, and then you can see here that it is having 1.544 Mbps bandwidth on serial link, so by default its cost would be 64 plus 165 plus 10 for this link, right? So total cost would be 75. So now we have two options: either we should configure the cost of this serial 1 by 1 as 1, or do one thing, on R4's F2 by 0 configure its cost as 64. Configure its cost as 64. So then after you will see that from R1 the total cost to reach either loopback of R5 or the loopback of R6 will be same. So let's do it now. Let's move on R4, and I'm gonna to modify the cost of F2 by 0 this time interface FA2 by 0 IPOSPF cost is going to be now 64. So this time you will see that from R1 total cost to reach both the loopback of R5 as well as the loopback of R6 will be same. So let's move on R1 now, and on R1 you can look at now show IP route 150.1.5.1, it is 75. To reach 6.1 it is also 75. Show IP BGP, but still its best path is via R5. You can see that, right? But this time you can look at here, so IP BGP 100.0. The IGP cost to reach next hop is same via both neighbors, which means that path selection was not performed based on IGP cost to reach next hop, because this time it is same via both neighbors. If IGP cost to reach next hop address is same via both neighbors, then next path attribute that will take place is, tell me, eBGP peering. eBGP peering, or you can say oldest path, or you can say oldest path. But remember, oldest path will take place if you are receiving prefixes from two different eBGP peers only. If you are receiving prefixes from two different eBGP peers, then this oldest path will never take place. This eBGP peering will be applicable only for eBGP neighbors, and this time this R1 is having only and only iBGP neighbors, right? So you can see here that it is having only and only iBGP neighbors, right? Fine. So what's next after eBGP peering? Router ID. So this time you can see which one is having lower router ID, 5 or 6. 5 is having lower router ID than 6. That is why R5 has won this election, or its best path is via R5. Even we are going to, now I'm going to manipulate this path selection in BGP by modifying their router IDs. So let me do one thing. I'll move on R6, and on R6 I'll change its router ID, and to change its router ID command is very simple. BGP router ID is going to be, let's say, 6666. So you will see that it will tear down neighborship with all neighbors and will re-establish them. Now you can look at here, so IP BGP summary, it must form neighborship with both of them. Yes, it has formed. Yes, show IP BGP, you can look at here now, its best path is now via R6, because this time R6 is having lower router ID. And you can look at here, show IP BGP 192.168.100.0 in more details. As I told you, in brackets it will always specify its router ID, neighbor's router ID, right? But before neighbor's router ID, it will compare IGP cost to reach next hop, right? So what will I do now? Again I'm gonna to configure cost of R4's F2 by 0 as same as previously. That was by default 1, right? So I'll move on R4 and I'll remove this command F2 by 0. I'm gonna remove this cost command from here. Let's move back again on R1, and this time you will see that metric will again become 12 to reach the loopback of R5. Yes, it is now 12, and that is best. So before router ID, IGP cost to reach next hop took place. Right? One more thing that you must remember now. Let's move again on F2 by 0, and once again let's configure its cost as 64. And once again you will see that for R1 its best path will become via R6. Let's move back again on R1. Show IP BGP, check it out. Now its best path should be or must be via R6. So yes, it is via R6 now, right? So its best path is now via R6 once again. But it is also possible that both neighbors are having same router IDs. Yes, it is also possible. Like you are having neighborship with same router, but you are having two different links, and onto those two different links you configured separate peering. You configured separate peering, like in this way. This is router 1, this is router 2. You are having two different links, two separate links, and you configured BGP separately for both links, right? So this time R1 will be having two peers, but both peers, because R2 is a common router, right? And a single process of BGP will be running onto R2, which means that it will be having single router ID, right? Which means that for our R1 on its neighbors, router ID will become same. So that's what I'm going to achieve it here on R5 and R6. On R6 I already configured 666. Now I'll move on R5, and on R5 also I will say BGP router ID is going to be now 6.6.6. So it is not like OSPF that it will not form neighborship. It will form neighborship, because here router ID will not will not obstruct to form BGP peering, right? It will not create any problem. Yes, if you are having same router ID on two peers itself, like for an example you configured same router ID on R1 and R2, might be that at that moment you can get some problems over there. But this time, because there is no peering in between R5 and R6, right? That is why you can have same router IDs on these two different routers. So now you can look at here on R1, show IP BGP summary. Still it is having neighborship with both of them. Show IP BGP, its best path is now via R5 once again. And show IP BGP 192.168.100.0. You can look at here via both neighbors. Now their router IDs are same. And if router IDs are same, then by default lower neighbor address will take place. That was the last tiebreaker, right? And neighbor address cannot be same. It cannot be same. It will never be same actually. If you are having two different neighbors, the neighbor address cannot be same. Tell me, is there any problem now? Fine. So right now in between R5 and R6 we do not have any type of neighborship. I mean, of course there is OSPF neighborship, but BGP is not running in between R5 and R6. Fine. So now let's start from wait. Right? So I'll start path attributes from wait, and you must remember that if you talk about the wait, it is a Cisco proprietary attribute. Very first thing, it has local it is locally significant, not has, it is locally significant, right? Default wait values for self originated it is 32768. Second, for received prefixes, right? For it is 0. Right? And you must remember, higher will always preferred. Then you must remember, BGP will never carry forward, will never carry weight value along with BGP updates, right? In BGP updates. That is why we said that it is locally significant, right? It will always used for manipulating outgoing traffic path selection. See, this is not outgoing prefix, this is outgoing traffic. It will always used for manipulating outgoing traffic path selection. Fine. You must remember the direction of data will always be opposite to the direction of your route. If route is incoming, then data will always be outgoing. And right now you can look at R1. R1 is receiving prefixes from R5 and R6. All these prefixes 192, in the range of 192, 168, 100, 101, 102, 103, all these prefixes, right? So for R1, all these prefixes are incoming prefixes, right? And of course traffic will be outbound. So right now you can look at R1 and show IP BGP. You can check it out that its best path is via R5. Let's assume that for R1 we want that its best path should be via, tell me, via R6 for all these prefixes, right? So what can we do? I'll move under BGP router mode. Router BGP 65500. Then I'll say neighbor 150.1.5. 6.1. Higher weight will always preferred, right? And by default weight is 0 over here. So via R6, if I configure its weight as 1, then it will also work. I mean it must work over here because 1 is higher than 0. Fine. So in this way you can modify your weight per neighbor basis. Do show IP BGP, have your changes taken place? Not yet. So remember, if you modify anything related to BGP path attributes, then you have to refresh your BGP prefixes. Then only your changes will take place. So this time we can say that do clear IP BGP star. And what is the meaning by in?
The prefix is coming from outside to inside. Incoming updates. Incoming.
Yes, we are forcing our neighbors to retransmit updates. With the help of this command, we are enforcing our neighbors to retransmit all the updates, right? So I will say do clear IP BGP star in. So once I will configure it, do show IP BGP. You see, via R6 now its weight value is 1. Fine. So its best path is become via R6 now. Do show IP route, even you can look at here. Do show IP route BGP. So via R6. But again there is a problem that for all prefixes its best path has become via R6. For all prefixes best path has been defined via R6. That's not good. Actually you should perform some load balancing. Like for some prefixes best path should be via R5, and for some of the prefixes its best path should be via R6. So of course we can achieve that with the help of route map, right? So this time I'm gonna remove it, because if I configure this weight value per neighbor, then it will change weight for all those prefixes which will be received from this particular neighbor. Just remove it, say do clear IP BGP star, and once again its best path will become via R5 for all prefixes, right? So again its best path has been defined via R5 for all prefixes. Now let's say for last two prefixes, for 102 and 103, I want that its best path should be via R6. And in case if R6 goes down, then its best path should be via R5. And in case if R5 goes down, then for all those prefixes for which it is having best path via R5, then it should define their best path via R6 automatically, in case if any one of the device goes down, right? I mean, there must be some redundancy. So right now there is redundancy, but there is no load balancing. There is redundancy, but there is no load balancing. So to achieve load balancing along with redundancy, what can we do here? Say IP prefix list, name is CCIE permit. So I just need to match last two prefixes only. So I'll be saying 102.0/23 greater than equal to 24 less than equal to 24. Any problem? And then I'll be creating one route map. Route map name is, let's say, wait permit. We are not performing route filtering, right? So we have to permit everywhere, right? We have to allow all the prefixes. Route map wait permit 10 match IP address prefix list name is CCIE, and for all these prefixes I have to set their weight as, let's say, 10 is also higher than 0, right? And then all other prefixes should come with the default attributes, right? With default attribute. So because you know very well that if prefix does not match with any entry, with any statement of the route map, then all those prefixes will be implicitly denied. So to allow all other prefixes, you have to create another statement for the same route map with higher sequence number. So this time I took its sequence number as 20, route map wait permit 20, and by default match all statement is there, and I'm not going to set anything over here, right? and via R6 I wanted to define higher weight value for these prefixes, right? So I have to apply this route map for neighbor R6 or for neighbor R5. Tell me, for which neighbor we should apply for, we should apply this route map, for R5 or for R6? Of course for R6. Via R5 it is already having its best path, right? So we just wanted to configure its best path for last two prefixes via R6. So of course for last two prefixes it must have higher weight value via R6. So this time I'll be saying that router BGP 65500 neighbor 150.1.6.1 route map name is what? Wait, in which direction? Do clear IP BGP star in do show IP BGP. Check it out. Now only for last two prefixes its weight value is 10 via R6, and that is why for last two prefixes only it have defined its best path via R6. And now you can look at its routing table as well. Do show IP route BGP. Check it out. For first two prefixes its best path is via R5, whereas for last two prefixes its best path is now via R6.
So we include information R5 को भी देना है.
Wait, have you understood it now? And you know that why do we use route reflectors? I think in previous class I discussed little bit about route reflectors, right? So this time now we have defined all these things, right? But there is a small problem now, and I'll let you know now that what is that small problem. First of all, let me remove this neighbor route map and all these things. So once again I'll be saying do clear IP BGP star in, and let me show you its BGP table of R1. So it is receiving all these prefixes from both neighbors, but its best path is via R5. Fine. Now we can look at R5 itself. This is your R5. Show IP BGP. अब एक महीने तक बंक मारोगे तो यही होगा ना फिर एक महीने बाद. यही होता है. गलती तुम्हारी थोड़ा ही है ये. अब ऐसा ही होगा. अब रुको, बाद में समझना ये सब चीज़ें, या बैच के क्लास से पहले या क्लास के बाद. Fine. So this time this R5 is receiving all these prefixes coming from Sprint US as well as from BT, British Telecom. Right? This R5. Similarly, R6 will be receiving all of them from BT only. Right? Fine. Now let's assume that R6 has lost reachability with BT, which means S1 by 0 has gone down. Show IP BGP does not have anything. It does not have now anything in its BGP table, which means for R6 there is no redundancy. However, we know very well that R6, R1 and R5, all of them are participating in same AS. So of course we should configure our network in such manner so that in case if R6 lost its connectivity with BT, then the lane users of R6 must still capable to reach all these 192.168.100.1 all these prefixes via R5. Of course it must have redundancy because we are having redundant connections. We are having two customer edge routers, but right now you can look at R6 that R6 does not have any redundancy. And you know why? Because R6 is having BGP peering with R1 only. It does not have direct BGP peering with R5. And this time R1 is receiving prefixes coming from one of the IBGP neighbor, that is R5. And you know very well that R1 is having two IBGP neighbors now, R5 and R6. And you know very well that what is the IBGP rule? If BGP speaking router receives anything from one of the IBGP neighbor, then it will never advertise them towards another IBGP neighbors. You remember that? So that is why R1 is receiving all the prefixes coming from R5 but is not advertising them towards R6. Right? So to solve this problem, now we have to configure this router 1 as a route reflector, means as a server. So which means that I have to move on now R1, and on R1 I have to say neighbor 150.1.5.1 route reflector client, neighbor 150.1.6.1 route reflector. So this time R1 has become now route reflector, whereas R5 and R6 have become route reflector clients. So this time if R1 receives anything coming from R5, then definitely R1 will advertise them towards R6 as well. So this time R6 must be able to receive all the prefixes coming from. So IP BGP summary, just to wait for a moment. Will take some time. This is R1, right? This is R1. So IP BGP. It is receiving them from R1. Fine. R6. We configured same router ID. We configure same router ID. That is why this R6 is not accepting all those prefixes. And in route reflector, you know, router ID will create a big difference now in BGP, right? So in future I'll be teaching you these route reflectors in more details, because at that moment I'll be teaching you cluster ID and you know, all these things, originator ID, everything. So this time actually their originator ID is getting matched, and because originator ID is getting matched, that is why this R6 is not receiving any prefix coming from R1. So this time what I need to do, I'll move on R5 and I'll configure this router ID as router BGP 65500. BGP router ID is, let's say, 5.5.5. That's fine. Again I'll move on R6 and you will see this time, see, R6 has received all the prefixes, right? So this time you are having redundancy, right? Let me do one more thing. Interface serial 1 by 0, say no shutdown. So this time I have enabled route reflectors in BGP in this topology, and R1 is working as a route reflector, RR. Right?
So in this case, what will be the data path from R6 LAN user towards?
Yes, let me show you one more thing over here. You know, in case of IBGP, next hop does not change automatically. Next hop address does not update automatically in case of IBGP neighbors only, right? And it has technical reason behind it. Of course, shortest path. You know why? If R6 would have received all the prefixes coming from R1 after updating next hop address, and then after you want it, let's say that from R6 I want to reach now, you know, these 192's prefixes. I think next hop self is not there, right?
Sir, yes, sir, but R5.
I think I removed it from R5, right?
Yes, sir.
Okay, neighbor 150.1.1 next hop. Oh no, it's not like that actually. Okay, it is receiving it from its EBGP neighbor actually. It is receiving it from EBGP neighbor. Okay, fine. Let me do one thing. Let me shut down this serial 1 by 0 once again on R6. So R6 will be receiving all these prefixes coming from now IBGP neighbor only, right? So IPBGP you can look at here now 150.1.5.1. Next hop is still unchanged. It is still same. This next hop was on R1 and R1 has given all those prefixes as it is to its neighbor R6. Now just imagine that situation if it would have updated its next hop address. And then after now you want to reach 100.1. First of all, R6 will be forwarding this traffic in the direction of R1 and R1 will be forwarding that traffic back into the direction of R5. But this time you will see that because next hop was not modified by R1. So from R6, if you want to reach now 192.168.100.1, then R6 will directly forward this traffic to R5, not to R1. However, R6, you see that you can look at R6, next hop is the loopback of R5. So by looking at BGP table, it seems that we received all these prefixes from router 5 itself, but actually we didn't receive all these prefixes from router 5. You can look at here, show IP BGP summary. Check it out. What's that? In actual, prefixes are coming from R1, but R1 didn't modify its next hop address. Just because of in future, in case if R6 wants to reach all those prefixes, it will not require to forward traffic into the direction of R1 first. And if it happens in that way, then you see that if if R6 wants to reach them, then R6 has to send traffic like in this way first R1, then R1 will forward that traffic back to R5, and then R5 will forward that traffic in the direction of BT, and finally BT will forward that traffic in the direction of New York router. So this is the reason, because in the background of BGP, especially in the background of IBGP, you will always configure IGP. So there will not be any problem related to reachability with the next hop address, and that is why in case of IBGP, next hop address will never get modified automatically. However, you can modify that manually, like I taught you before, right? With the help of route map, and I used route map to modify next hop address in case of IBGP peers. Understood? So now you can look at again R6 and you can see show IP BGP 191.168 in more detail, right? Check it out. In actual, this is your next hop address, right? We receive from this neighbor and this is neighbor's router ID. So in actual, we are receiving all these prefixes from neighbor R1, but next hop is still the loopback of R5. So that whenever it will require to reach all those prefixes, it will reach them via R5 directly, without traversing R1. So this is the technical reason, so that in case of IBGP, it does not modify their next hop addresses automatically. Right? Fine. One more thing I would like to show you here. Now S1/0 say no shutdown. You will see that now neighborship will come up in between R6 and British Telecom. Neighborship has came up now. Fine. Let's do one thing. Let's move back again on R1. R1 is receiving all these prefixes coming from both neighbors. Check it out. Guys, look at here. ओ मोबाइल बाद में पढ़ लेना ये मैसेजेस. it is receiving all these prefixes coming from these two neighbors R5 and R6, and it has received all these prefixes, right? And to reach them, its best path is via, tell me, R5. Now you know very well the algorithm that works in the background of BGP, that it will always advertise its best path information towards its neighbors. So for R1, its best path to reach all these 192's prefixes is via R5. So definitely it must advertise its best path information towards R6 now. And you already configured this router as a route reflector, right? So of course it must reflect all these prefixes towards its IBGP neighbor, right? So this time let's move on R6. That is why R6 is receiving all these prefixes coming from eBGP neighbor, that is, you know, BT. You can look at here that it is connected with BT directly, right? It is receiving all these prefixes coming from BT, as well as it is receiving same prefixes coming from its IBGP neighbor R1. Is not it? But for R6, its best path is via BT itself. You can look at here in BGP table. You can look at BGP table. BGP table is showing us that its best path to reach all these 192's prefixes is via BT. You know why? Okay. Before eBGP, there are so many things. First of all, it will compare next hop reachability. So this time next hop is reachable via both. I mean, like the 150.1.5.1 is reachable, 201, 100.1 is also reachable. All these things are reachable. Local preference is what? Now, as I told you, whenever you will be giving an update to your eBGP neighbor, local preference will never be included in your BGP updates if BGP updates are going towards eBGP neighbors. That is why this time, because you know this is eBGP peer 201 100.1. This is our eBGP neighbor, and that is why when it received this prefix from this eBGP neighbor, it is not having any value under local preference. Any problem? I have one problem. We always says that higher local preference will always preferred.
But since one side is not applicable, so how can
We always says that higher local preference is always preferred. We always says that, right? Fine. But this time, you know, via R5, its local preference is 100. And via eBGP neighbor, it is null. Remember, if it is null, it assumes that it is 100. If under local preference, it is not displaying anything, if it is blank, then it by default assumes it as a 100. Default local preference.
machine cannot
Is not it?
cannot implicate not applicable.
Don't say that not applicable. Even I can prove it right now. See, do one thing. YR5 configure higher local preference, and then you will see that its best path will become YR5 itself. Although via eBGP neighbor, still it will remain as blank. Let me do that. You see, I'm moving on R5. By default, local preference is what? 100. I'm gonna to change it now. BGP default local preference is 101 now. And now look at R6. Its best path is now via, and still it does not have any local preference value via eBGP. That's why I said that it assumes that it is by default 100. Tell me. I hope that now your small doubt is cleared. That if it is blank, then again it will assume it as a 100. Let's move back again on R5. Let's remove it, and again by default its local preference will become 100. So let's move back again on R6, and you will see that once again its local preference will become 100. So again its best path is via eBGP. You know why? Because local preference is same than self-originated, nothing. It is not gonna to compare self-originated because no one is self-originated, right? Then AS path attribute is same. Origin code, say metric 0 and nothing. If it is not anything, then again it will assume it something like 0, right? So it is same. Then again external over internal. So external is preferred over internal. Understood? And now again in BGP there is a rule that it will always advertise its best path information towards its neighbor. So for R6 its best path is via BT. So that is why now R6 will also advertise all these prefixes in the direction of R1. That is why R1 is receiving them from R6. As well as if you look at R5, show IP BGP, check it out. It is receiving from Sprint as well as BT.
These are both
It is not. Yes, R5 is having EBC peering with Sprint as well as with BT. Via Sprint it has to across 3 ASs. Via BT it has to across only 2 ASs. That is why its best path is via BT, not via Sprint. To reach all these prefixes. Hope you people are getting, all these things. So finally, and you could ask me that, sir, R5 is not receiving anything from R1. You know why? Because for R1 its best path is via R5 itself. For R1 to reach all these prefixes, best path is via R5 itself. That is why R1 will never give this information back to R5, because R1 is receiving best path itself via or from R5. So remember in BGP there is a rule that let's say that I received some prefixes from my neighbor, and via that neighbor I'm having my best path, right? So I will never advertise those prefixes back towards that particular neighbor, right? I can advertise all those prefixes towards all other neighbors, but we cannot advertise, BGP cannot advertise those prefixes, those updates towards that neighbor via which it is having best path. Understood? Fine.
So this R5 and R6 both are clients router spectrum, and they exchange updates.
Of course they will change
So
now.
why R5 is not showing this third router via R5?
Via R6. R5 is not.
R6, sorry.
Yes, because R5 and R6 they do not have direct IBGP peering, right? R5 will be receiving updates coming from R1 only, and for R1 its best path is via R5 itself. You see, you look at BGP table of R1, its best path to reach all of them is via R5. So it is not gonna to advertise this information back towards R5 that okay, this is the best path, right? Because its best path is via R5 itself. But it will definitely advertise this information towards R6 now. Understood? So that is why R6 is receiving it from eBGP neighbor as well as IBGP neighbor. Now in case if I move on R1 and if I define its best path via R6, then you will see that R5 will be receiving from eBGP neighbors as well as IBGP neighbors. Let me show that. Let me show you. On R1, router BGP 65500, neighbor 150.1.6.1, weight is like 5. Say clear IP BGP star in. Show IP BGP. Now its best path is via R6, right? And this time if you look at R6, you will not get anything. Like previously it was receiving from IBGP neighbor as well, but this time it will be receiving from EBGP neighbor only. But this time if you look at R5 from 3 different neighbors. Understood? But as I told you that wait will never be carried forward in BGP updates. However, this R5 is receiving updates coming from R1. Right? You see, that is this one, right? But still its weight is what? 0. Whereas on R1 weight value was 5. So if weight was coming into the update, then it should have received that weight value onto R5 as well. But this time it is not receiving anything like that, which means that weight is locally significant. Right? And along with that, one more thing has proved that we modified weight on R1 and it manipulated path selection of R1 only. It have not forced R5 to manipulate its path selection. For R5, its best path is still via BT. However, all of them are in same AS. You see, R1, R5 and R6, all of them are in same AS. I modified weight value on R1, but by modifying weight on R1, it is not impacting on R5, which means it is having locally significant. Understood? Fine, weight is completed now. And also I have told you that how can you get redundancy along with the load balancing. So once again, let's move back again on R1 and let's remove this command router BGP 65500. Let's remove this command. And do I still require to teach you this weight attribute once again with using route map, or is it fine now? Fine. So let's go for local preference now. You see, for R1 its best path is now via R5, just because of lower router ID, right? What can we do? We can configure higher local preference via R6. So by default local preference is 100 in BGP, right? So what can we do? You know very well that R6 is receiving all the prefixes coming from EBGP neighbor and advertising them towards IBGP neighbor. But before advertising prefixes towards IBGP neighbor, it will add default local preference, and that is by default 100. So this time R6 has added 100. But what can we do? What can we do on R6, or what can we configure? That is router BGP 65500. We can say BGP default local preference, and let's say it is. And you can configure your local preference up to, and this is the way by which you can modify the default local preference of BGP, right? This is the command, and by default it is 100. So this time you will see that now whenever R6 will advertise any single prefix towards R1, its local preference will be now 101. Let me show you now on our R1 this time. Wow, its local preference is 101. But this time we are having one another change in its BGP table along with local preference. Previously when we modified weight, till that R1 was having both routes in its BGP table, but this time it is having only one path, and that is via R6 only, right? Fine. Let's move on R5 now. Why R5 is not giving this information back to R1? Let's move on R5 now. Try to BGP check it out. This is your BGP table on R5 now. Even for R5 itself, its best path has become via. That is why I said that local preference does not have locally significance. It is not locally significant. It will always carry forward within BGP updates. That is why we modified local preference on R6, but it has given that information to R1. Even on R1's BGP table, you can see that its local preference is 101, which means that this information is coming along with BGP updates, right? And then further R1 will be giving this information to R5, and R5 is there, and you can look at here that R5 is even R5 itself is receiving this modified local preference. And because for R5 its best path has become via R6, that is why it is not giving this information back to R1 now, because it received its best prefixes from R1 itself. Are you getting my point? This time R5 is receiving best path from R1 itself. That is why R5 is not advertising these prefixes back into the direction of R1, and that is why R1 is receiving these prefixes from R6 only, not from R5. You understand? And now let me prove that whenever BGP will be giving an update to its eBGP neighbor, it will never add local preference, or it will strip local preference value, right? So this time for R5 its best path is via R1 and local preference is 101, which means now R5 is going to advertise its best path information to its neighbor Sprint US. Are you getting my point? Of course R5 must advertise its best path information towards its neighbor Sprint US. So let's move on Sprint US now, and let's check its BGP table. Yes, it is receiving them from 205.100.100.5, and that is the R5's IP address. You see, this is R5's address. And is there anything under local preference? No. You know why? Because whenever BGP updates will be forwarded towards eBGP neighbor, it will never carry forward local preference value along with BGP updates. Understood? Fine. But this is completely, wrong. Completely wrong. This way to modify local preference is completely wrong, because for all prefixes its preferred exit point has been defined R6, even for R5 itself. And again, remember, if you talk about the local preference is not a Cisco proprietary attribute, right? And it does not have local significance, but it will never cross its AS boundary. It will never cross its AS boundary. Default value is 100, right? And higher will always preferred, right? Higher will always preferred. Fine. So this time this is the wrong way to change local preference, because for all prefixes its preferred exit point has become R6. So let's move back again on R6 and let's remove this default local preference now, router BGP 655.0.0, and remove this default local preference. And once you will remove it, you will see that for R1 again its best path will become via R5. Fine. Now R1 is receiving all these prefixes from its neighbors R5 and R6, and for all prefixes its preferred exit point is R5. We want that for first two prefixes 100 and 101 its best path should be via R6. To achieve that, what can we do? We can say router first of all create one prefix list, IP prefix list. I think I was already having one prefix list over here, right? So say no route map first of all, that was I think wait, right? And no IP prefix list, that was I think show IP prefix list. Is there? No. Fine. IP prefix list CCIE permit 192.168.100.0/23 greater than equal to 24, less than equal to 24. So first two prefixes will match with this entry, right? And then you will be creating one route map name with LP local preference permit 10. Match IP address prefix list, that is CCIE. Set local preference how much? Even you can set 110, right? And for all other prefixes, all other prefixes must come with the default local preference. So what can we say? We can create another statement for the same route map with higher sequence number, that is 20. We could take 11 as well, right? It is not always necessary to take 20. After 10 you can also take 11, right? Fine. Then after, you don't need to match anything because by default it is match all. By default, match all statement is always there under route map, right? And then you don't need to set anything. Then go to router BGP 65500 via neighbor 150.1.6.1, because via R5 it is already having its best path, right? So we just require to configure higher local preference via R6. So I'll be saying neighbor R6 and route map, and name is what? LP. In which direction? In. Say do clear IP BGP star in, and then say do show IP BGP. Check it out. For first two prefixes, local preference has been configured as 110 on R1, right? On R1 we configured it, and then after you can look at R5 as well, because its best path is now via R6, so it will be advertising this information towards R5 as well. So you will see that for first two prefixes, its best path will become via R6 itself. Check it out. Now it is not via eBGP neighbor, right? Because before external, internal local preference will take place, and this time it is receiving modified local preference. Via eBGP neighbor it is not having any local preference value, but by default it will assume it as a 100, and 110 is higher than 100. That is why its best path has been defined via R6, right? So this is the way by which you can change your local preference. And see, still we are talking about outbound traffic, right? We are manipulating path selection for outbound traffic only. Like we are receiving prefixes coming from our neighbors, and then traffic is forwarded out from our network, right? We are forwarding traffic, right? See, R1 is receiving all these prefixes, which means R1 will be forwarding traffic towards those prefixes, right? For those prefixes via R5 or via R6. So sometimes we want that, okay, traffic should go via R5. Sometimes we want that traffic should go via R6. So accordingly we are manipulating path selection, right, with using all these path attributes. So again we are using this local preference to manipulate outgoing path selection. But remember, you cannot use this local preference value to manipulate incoming traffic path selection. You cannot manipulate incoming traffic path selection with the help of local preference. You know why? For an example, let's say that this customer Network Bulls Technologies is also advertising some of the prefixes, right, towards ISPs, Sprint and BT. Now we want to manipulate path selection of BT. Like whenever BT will forward traffic into the direction of customer Network Bulls Technologies, it should use only link 2 or link 3. Let's assume that, right? Let's say we want that BT should use only link 2 to forward traffic in the direction of customer Network Bulls Technologies. We cannot achieve it by modifying either weight or local preference, because weight has local significance, whereas local preference is locally to an autonomous system. So whenever you will be giving an update to your eBGP neighbor, so local preference will never be carried forward within BGP updates. So whenever R5 and R6 will forward traffic into the direction of BT, then BT will never, because BT will never receive local preference, right, along with BGP updates. So we cannot manipulate path selection of BT for that traffic which is which will be coming into the direction of customer Network Bulls Technologies. Right? Fine, so we have changed local preference in this manner now. I'm going to remove it from here now. Do clear IP BGP star in do show IP BGP. Once again, its best path is via R5 for all the prefixes, right? It is not always required to change local preference like on R1 only. Even we can modify this local preference on R6 as well. And you see, I want that for first two prefixes, एक तो एक महीना वैसे ही नहीं आया, ऊपर से सर के ऊपर से जा रहा है, और ऊपर से फिर बातें भी हो रही हैं. ये तो सारी बातें गलत हो रही है ना. एक कम से कम कुछ बातें तो मेरे फेवर की होनी चाहिए ना, या तो समझ में आना चाहिए आपको. अच्छा आ रहा है, चलो कर लो बातें. तो show IP BGP right on R6, and we can see that all these prefixes have been received by R6 from its neighbor R1 as well as from its eBGP neighbor BT, and its best path is via eBGP neighbor, and of course it should be. And now what I want, my task is like for first two prefixes 100 and 101. See, we just have the console of R6. We just have control of router 6 in this diagram, and someone asked me to do configuration in BGP so that for all the routers in AS 65500 their best path should be via R6 for first two prefixes, and we are just allowed to do modification on R6. So we can do it in this manner, like I can move on R6, and on R6 I'll be creating access list, I'll be creating prefix list itself. CCIE permit 192.168.100.0/23 greater than equal to 24 less than equal to 24, and then I'll be creating one route map name is what, CCIE, or we can create LP local preference permit 10 match IP address prefix list name is CCIE. Then to allow all others a higher sequence number, let's say it is 11, match all. Okay, I think we didn't set local preference, right? Set local preference is what, 120 this time, right? So I have set it. I've created this route map. Now you can look at this show run pipe section route map. So there is only one route map available on R6, and I'm using that route map for local preference. You can see that we are having two statements for this route map. One statement is with the sequence number 10, another statement is with sequence number 11. Under sequence number 10 we have said that okay, for all those prefixes which will match with prefix list CCIE, for all those prefixes it must set its local preference as 120, and for all other prefixes which do not match with this prefix list will match with this statement of this route map, because match all statement is there, and we haven't set any local preference under this statement of this route map, right? So all other prefixes will be allowed, but with the default attributes. So this time what can we do here on R6? We can move under router BGP 65500. We can say neighbor 201 100.100.1, right? And route map, see, this is my eBGP neighbor, right? And route map name is what, LP, in which direction, in. It is also possible to configure. It does not mean that we are receiving local preference from my eBGP neighbor. No, I'm simply saying that whenever I'll be receiving any prefix from this particular neighbor, its local preference should be configured like this. So now it does not matter whether default local preference is coming from this particular neighbor or not, right? And now exactly. So this time you will see that the BGP table of R6 for first two prefixes local preference. Okay, do one thing, say clear IP BGP star in, say show IP BGP, check it out.
और अभी पूरी ऐसे प्रोपोगेट करेंगे.
Of course. Now see, for R6 its best path is via eBGP, right? And with local preference 120. So previously it was not having any local preference under local preference attribute, right? Because it was by default, it was blank, but it was considering it as a what? Done. So for R6 its best path is via BT now, and now let's move on R1, show IP BGP, right?
Sir, R5 is
What?
R5.
What R5? It's R6. I changed for first two prefixes, not for last two prefixes. I'm on R1, and on R1 for first two prefixes its best path is via R6, and not only on R1, even if you look at R5,
Yes,
its best path is via right. So remember, local preference will always carry forward within BGP updates. Apart from that, you are also having one another option. If you do not want to apply this local preference in this manner, do one thing, router BGP 65500, just remove it from here, and then say neighbor 150.1.1.1 route map name was LP in which direction, because this time we are giving an update to IBGP neighbor, right? This is IBGP neighbor R1. So whenever it will advertise all these prefixes towards this IBGP neighbor, it will set its local preference as 120. For what? ऐसा थोड़ा ही ना है, वो R1 फिर R5 को भी देगा. See, if you are changing local preference, it will affect all routers path selection. It will be effective in an entire autonomous system.
So sir, if 150.1.2.1 is also a member of a IBGP neighbor, in that case it will not received by that.
Say again.
If R2 is also a IBGP neighbor. And
R2?
Yes sir. In that case, if you are
R2,
yes,
R1.
Right now R1 is there. If R2 is also there, in that case it is not effective.
With whom? I mean, R2 is,
R2 with R6 and R5.
of course, R2 will also receive them from R5 and R6, and it will affect R2 as well. Because see, there is a simple rule: if I am receiving any prefix from one of the neighbor, I will advertise them towards all other neighbor. Is not it?
Okay, it will receive that from R5.
Of course, R2 will be receiving from R5 as well as from R6, but it will be receiving prefixes coming with higher preference, higher local preference from R6. So its preferred exit point will be R6 for all those prefixes. With
in that case, you are saying that neighbor 150.1.1.1 के लिए आपने
then you have to apply for 2 as well. Of course, of course.
Statement is effective only for that.
Exactly. That is why usually you will prefer to configure this local preference for your EBGP neighbor only for for incoming updates.
Yes.
For incoming updates, right? However, you are applying this route map for incoming updates, but it is affecting outbound traffic path selection. Right? Because if you are applying, see, this route map for this for its IBGP neighbor British Telecom, then of course it will be applicable for all IBGP neighbor automatically, right? But if you are applying it in this manner that I applied it recently for R1, like R6 on R6 I configured this route map for its IBGP neighbor R1, but in case at same time if it is having neighborship with R2 as well, then it will not affect R2, right? And let's say that there is no neighborship in between R1 and R2.
In that case, it is not used on local rate.
Fine. So I have told you that how can you apply all these things, right? So say do clear IP BGP star out as well as you can say in. So this time you will see that in R6 BGP table, once again local preference will be null, because this time you haven't, we have removed that route map for this eBGP neighbor for its incoming updates, right? Incoming updates, see there are two things: incoming update, outbound traffic.
Yes, sir.
Let's move back again on R1, show IP BGP, check it out, and once again you will see that for first two prefixes best path is via R6 itself, and local preference is still 120. Even for R5 as well, its best path will be Is there anything else that we can discuss in local preference? We have manipulated path selection with using all the methods, with using local preference and wait attribute. Next attribute is going to be now AS path attribute. Self originated is also there, but forget about it, you can do it by yourself. Even self advertised will never take place, because for self advertised wait is always 32768, so path selection will be performed by wait itself. Next is AS path attribute. AS path attribute is a well-known mandatory attribute. AS path attribute is a well-known mandatory. And do you understand the meaning by well-known mandatory? Yes. Meaning by well-known mandatory is it will always carry forward this attribute within its updates, whether updates are forwarded towards IBGP neighbor or eBGP neighbor, doesn't matter, right? Now I'm gonna to remove this local preference from R6 first of all. No route map. Moving on R1, show IP BGP. Once again, its best path is via R5. Remember, with using AS path attribute, we can manipulate path selection for outbound traffic that we performed with using wait as well as local preference. We can use, similarly we can use AS path attribute. But why? If we are already having local preference and wait value or wait attribute to manipulate outbound traffic path selection.
If you want to affect the path selection outside an AS boundary.
If we want to manipulate, in most of the cases you will find that AS path attribute will be in use to manipulate incoming traffic path selection. Incoming traffic path selection, and I will implement this AS path attribute to manipulate both. Yes, to perform both type of manipulation for incoming traffic as well as for outbound traffic. So first of all, for outbound traffic, same as similar to local preference and wait. So this time we can see that for R1 its best path is via R5. You understand? We want that for last two prefixes, once again last two prefixes 102 and 103. We can also say that for 101 and 103, it's not always correct to say that okay only for last two prefixes or first two prefixes, for any prefix, because in prefix list you can match any prefix. In ACL you can match any prefix. So this time let's do it for last two prefixes. For last two prefixes, its best path should be via R6. And we have to achieve it with the help of AS path attribute this time. We are not allowed to use either weight or local preference. However, of course, we will always prefer to use either weight or local preference to manipulate outbound traffic path selection. This is not the correct way to use this AS path attribute, but I'll be using that first, and then finally I'll teach you that how can we manipulate incoming traffic path selection with the help of AS path attribute, right? So first of all, let's do it now for outbound traffic path selection, right? We know very well that for last two prefixes, its best path is via R5, and via both the neighbors it has to cross only two ASs, one 35500 and another one is 8127, right? And this last AS in AS path list specifies that okay, actually in actual these prefixes were originated by AS 8127. Fine. If I want to define its best path for last two prefixes via R6, then do one thing via R5, add some more ASs in AS path list. Add some more ASs in its AS path list. See, this list is called AS path list. So in this AS path list, add some more ASs so that understood. Now point is, we could remove one of the AS from this AS path list via R6 as well, instead of adding ASs in AS path list via R5. But remember that if you talk about AS path list, in AS path list you cannot remove any AS from that list, but you can add some more ASs, same as offset list. Do you remember offset list? In RIP and EICRP we used offset list. So with using offset list you can add metric, but you cannot reduce the metric. Similarly here, there is a concept in BGP that is called AS path prependation. That is called AS path prependation. With using AS path prependation, you can add some more ASs in its AS path list, but you cannot remove any AS from existing AS path list. So this time what can we do? Via R5 we can add some more ASs in its AS path list, right? So let's do that now. Do show IP prefix list for last two prefixes, right? Okay, then we have to do one thing, no route map. Its name was no IP prefix list, name is do show IP prefix list, no prefix list, IP prefix list, CCIE permit 191.68.102.0/23 greater than equal to 24 less than equal to 24. Then route map, right? Route map name is AS underscore path permit what? Sequence number 10. Then say match IP address prefix list, name is CCIE set AS path prepend and prepend some more ASs, and we can say 100 200, right? Because we are not using these ASs anywhere in this topology, right? So I'm prepending these ASs in its AS path list. So I said set AS path prepend 100 and 200, but AS path prependation will be performed only for those prefixes which will match with this prefix list. And what about all those prefixes which will not match with this prefix list? They will be implicitly denied. To allow them, you have to create another statement for the same route map 11. Do not match anything, do not set anything, because by default match all is there, and we don't need to set anything. We want to receive all other prefixes with default attributes, right? So finally I'm gonna to see for which neighbor you will apply this route map this time, for R5 or for R6. For R5, because via R5 we want to receive prefixes with a higher number of AS path, with higher number of ASs, right? So this time I will be saying router BGP 65500 neighbor 150.1.5.1 route map name is what? AS underscore, I think it was path, right? Yes, that was. In which direction? Say do clear IP BGP star in. Do show IP BGP. Check it out. So now its best path is via R5 itself. Changes have not taken place. Your changes didn't took place. Remember, if you are receiving an update from an IBGP neighbor or you are giving an update to your IBGP neighbor, you cannot perform AS path prependation. For IBGP neighbor, AS path prependation is not allowed. You know why? In real scenarios as well, when BGP is giving an update to its IBGP neighbor, it does not prepend its own AS itself. So remember, as I told you before as well,
Yes, yes.
prependation will be performed for EBGP neighbor only. Whether you are giving an update to your EBGP neighbor or you are receiving an update from an EBGP neighbor. But remember, prependation can be configured for EBGP neighbor only. Right? So I'm gonna remove it from here. Do show history. I'll copy all these commands and I'll paste on R5 because R5 is receiving all those prefixes coming from BT, right? I'm going to shut down the serial 1 by 0 on R5. Yes. Shut it down. I will not be having any other option at this moment now, right? So BGP is receiving prefixes from this BT after crossing these ASCs. Now what can I do? I will copy from R1 and paste on R5. Show IP prefix list. So there is only one prefix list to show history. I have created this route map. I have configured this route map, same route map on R5. And this time I'll be saying do show IP BGP simply. Check it out. Router BGP 65500. Neighbor is my 200.105.100.1. That is BT's address, right? You can look at here. This is the address of BT. So I have to say that whenever you will receive any prefix from this neighbor, then you have to use route map. What? AS path in which direction? Because it will be receiving updates from this neighbor, right? So this time, whenever it will receive all these prefixes from this particular neighbor, it will add or it will perform AS path prependation. Now you see do clear IP BGP star in. Sorry. Show IP BGP. Check it out. For last two prefixes 102 and 103. See. Now its best path is via R6. Its best path has been defined via R6 automatically. Is not it? I just modified configuration on R5 only. Because via BT, now it has to across how many ASCs? 4. Via R6 it has to across only 2 ASCs. Tell me. So even for R1, automatically its best path will become via R6 for last two prefixes. Because for R5 itself, its best path was via R6, right? So in this way, we can use this as path prependation to manipulate outbound traffic path selection. But in actual, you will not be using this as path prependation to achieve this task, because you could use either weight or local preference to achieve same task. Then what is the uses of as path prependation? We will be using this as path prependation to manipulate incoming traffic path selection. Let me do that now. You see now that on R1 I'll be creating some loopbacks. Loopback 1, IP address 100.1.1, 2, that is 2, loopback 3, and this is going to be now 3, loopback 4, and this is going to be now 4, loopback 5, and this is going to be now 5. Router BGP 65500, network 100.1.0, mask is going to be I have advertised them from R1, right? I must receive them onto BT from R5 as well as from R6. Let me check out on BT. So IP BGP, of course, it must receive all of them. It has received very first prefix, but it will be receiving all other prefixes too sooner. You see, and by default, its best path is now via R5. You see, this is the address of R5. This is the address of R6, right? So for BT, you see, whenever you must receive all of them on Neo router as well. So IP BGP. Check it out. If you say trace route 100.1.1, you will see that you will be going through. Just wait for a moment. Router BGP 8127, network 80.1.0, mask. That is why, you know, the reply was not coming for of trace route, right? So now do one thing, trace route, and you see it is going via, and then after you are having a black hole on R3 and R4. That is why reply will not come from R1. But at least on Neo router you have seen that it is going via R5. Even if you trace route 100.1.5.1, then also it will go via. Oh, for 5.1 it is 6. Why? On BT. Okay, for all other prefixes it is 6. For very first prefix it was via 5. But you know, if you say clear IP BGP star, that is hard reset, right? I have done hard reset for BGP. Prefixes will come once again. So IP BGP, it has received all the prefixes, and you can see that this time its best path for all, it is via R5. So this time if you look at Neo router, so IP BGP, check it out. Check it out, it has received them 100.1.1, and if you trace route 5.1, every time you will go via, you will get enter into customer network bulls network, into the enterprise network of customer network bulls via link 2 only, which means link 2 will become overutilized very soon, and link 3 will remain as, will remain underutilized. How can you solve this problem now?
कुछ के लिए इधर से पेस्ट करा देते हैं, कुछ के इधर से पेस्ट करा देते हैं.
Of course, we can do that with the help of AS path prependation. What I want now, that for first 3 prefixes, BT should send BT should send traffic via link 2 for 100.1.0/24 to 100.1.3.0/24. For these 3 prefixes, BT's preferred path should be link 2, but for 4.0 and 5.0, BT's best path should be via link 3. And one more thing, there must be redundancy. In case if link 2 goes down, for all other prefixes, for BT's best path should be link 3. If link 3 goes down, for all prefixes, best path should be link 2. And right now, for BT, any link can become best. Any link. Right now it is link 2. In future it can be link 3. Then it can be link 2. I mean, it can be any link, right? But you have to make sure that for first 3 prefixes, BT's, I mean, if link 2 is available, then for BT its best path should be link 2 only. And if link 3 is available, then for last 2 prefixes, for 4 and 5, BT's best path should be via link 3 only. And we do not have access of BT. Customer wants this thing. Customer is having one site that is running AS65500, another site is in New York that is running AS8127. We came to know that link 2 is is overutilized, so we tried to trace route from New York router, and we came to know that for all prefixes traffic is going via link 2 only. For any single prefix, BT is not forwarding traffic into the direction of customer network Bulls Technologies via link 3 for any prefix. That is incorrect. That is not good actually. But you cannot manipulate the path selection of BT because you do not have, you do not have the access of BT router. So how will it be possible for, to manipulate path selection of BT? For that purpose, we are having this AS path attribute. We can do it with the help of AS path attribute. Are you getting my point? So this time, and one more thing, in case if you are performing prependation, AS path prependation, then make sure that you must prepend same AS from where you are receiving an update or from which AS you are giving an update, because AS path prependation can be configured in both directions. Right now we configured it on R5 for its inbound updates, for its incoming updates, right? So make sure that you are prepending only AS35500, not any other AS. And if you are giving an update to BT and then you want to perform prependation, then you must make sure that you are prepending only 65500. I mean, same number can be right or can be prepend in AS path list multiple times. Same number can be prepended in your AS path list multiple times, and it will be counted different AS actually. It will be counted as different AS. कोई बात नहीं, चलो पहले करके दिखा देता हूँ. I'll stop this task for now. Look at R1. Show IP BGP. Show IP. Yes, show IP BGP. It is receiving last 2 prefixes from 6, and its best path is by R6, right? Let's say that R1 is also having neighborship with R2. Let's configure neighborship with R2 as well, right? And R2 is running, let's say, AS200. So I'll be saying router BGP 65500, neighbor 150.1.2.1, remote AS is what? 200, and update source is loopback 0, and then we can say eBGP multi-hop is 2, right? Then I'll move on R2. I'll be saying router BGP 200, neighbor is 150.1.1.1, remote AS is 65500, neighbor 150.1.1, update source is loopback 0, neighbor 150.1.1, eBGP multi-hop is 2. Just wait. Neighborship has came up. Show IP BGP. You have seen that it has received all of the prefixes, right? It is receiving 103, 102 as well, right? And it has, see, next hop has been changed, because for eBGP it will update its next hop address automatically. So this time we are having this neighborship between R1 and R2 as well, but this time it is eBGP neighbor, right? This time They are having ABGP peering. Fine. After it, what happened that R6 lost connectivity with BT, which means now R1 will be reaching all these prefixes via R5 itself. You can move on R5, sorry, on R1, and you can see last two prefixes have been injected by R1 in its BGP table via R5. But R5 is prepending those two ACs, 100 and 200. If you now if you move on R5, sorry, on R2, this is R2, right? If you look at the BGP table of R2, see 102 and 103 is not available due to same AS, because it is running AS 200 itself. So it is discarding all those prefixes, right? And 102 and 103 are containing AS 200. Understood? So it is always recommended, see, in place of, like on R5 you prepended AS 100 and 200, in place of that you must prepend only and only 35500 multiple times. Like here on R5, inside route map you do one thing, go to route map, and instead of saying set AS path prepend this, say set AS path prepend 35500 35500 two times, right? And then say clear IP BGP star in. Once you will say it, you will see that on R1, see 35500 multiple times, and this time R2 will also receive all these prefixes. That is why it is always recommended to prepend only that AS from where you are receiving your prefixes. Just to wait. Fine. So you should be very careful if you are going to configure AS path prependation.